So this video will be an attempt to show that this series is converging or diverging using the direct comparison test. Now we know what to choose for an. An will come from the terms in the original series. But the question now is, what should we choose for Bn? And it is probably ridiculous if you try a geometric series for Bn, because there is no way you can compare this to any geometric series. So this is out of the question. So then the next thing will be P series. So what kind of P should we choose? What kind of P should we choose? If we choose P equals to 1, then we are suspecting that our original series is diverging, right? But this doesn't seem to be diverging, because this thing here gets smaller than any power of n. Even 5 eventually becomes smaller, because this thing gets very, very big very fast. So if you get very big very fast, then the being in a denominator, the reciprocal will be small very fast, right? By very fast, we mean as n gets very, very large, large enough, 1 over n factorial will be smaller than 1 over n to the 5. So I think this will be true for any n that is big. Yeah, big. So for example, of course this is also true for n equals to 1, but that's useless comparison test. So I think the original series is in fact converging, and we can use any P as long as the P series is converging. So I'm going to erase everything and try P equals to 2. Alright, because P equals to 2 works and P equals to 3 also works. So let's do the easier one. Let's do 2. Oops. So is it true that 1 over 1 factorial is smaller than 1 over 1 squared? Well, it's equal. That's true. 1 over 2 factorial, is it less than 1 over 2 squared? That doesn't look like it's true, right? It's not true. 1 over 3 factorial, is it less than 1 over 3 squared? No, that's not true either, right? But eventually you'll be true. Let's see, 1 over 4 factorial, is it less than 1 over 4 squared? This is beginning to be true, right? Because this is only 1 over 4 times 4, whereas this is 1 over 4 times 3 times 2 times 1. So this is already 6 times 4. This is only 4 times 4. And the rest will be true, because 1 over 5 factorial is going to be less than 1 over 5 squared, because this is only 5 times 5, but that is 5 times 4 times 3 times 2 times 1, which is much bigger, and so therefore as a fraction you'll be smaller. So now we know, and we're going to show that this is true. But how big should n be? A moment ago we see that as long as n is bigger than 4, it will be true, because you see, initially it's not true. Initially, well, for n equals to 2, n equals to 3 is not true, but eventually it will become true. So here's what I do. 1 over n factorial, it's really 1 over 1 times 2 times 3 all the way to n, whereas 1 over n squared is just 1 over n times n, right? And this will be true. So this is called Bn. That's called An for n, let's see, big enough. So we have that inequality. Now we just have to establish that the fact, since blank, and we have to give some reason, by the direct comparison test, and this is direct comparison test part I, an, which is sum 1 over n factorial, also blank. So this is converges because it's a p series and p is equals to 2, and so this also converges. And that's how we prove that series is converging for exercise 11.